Hey guys, welcome to Code Templar. This is day 6 of FAANG series, and today we will solving another Leetcode problem, House Robot 3. This has been asked in Google, so let's jump to the question first. Here, basically the thief wants to steal from houses which are arranged in a tree structure, basically binary tree structure, okay? And each house holds some money. However, he can't rob two houses that are directly connected, parent and child, or the police will be alerted. So let's jump to the example 1. Okay, and we need to maximize the profit, okay, in this problem statement. So let's take example 1. See, um, if we are selecting the root node 3, then we won't be able to select its left or right child 2 or 3. Why? Because that root node is directly connected with the left and right child. Okay, so in this problem, if you see the maximum amount of money the thief can rob is 7. And how it comes? He selected the root node, then its left child ka right child node basically, and similarly he's selecting the other right child, its child node basically. So here the maximum value which we get is like 3 plus 3 plus 1. Let's say if we would have selected 2 and 3, then in that case we'd have make the profit only 5. Hence we are selecting the root which is at level 1 and 3 and 1 which is level 3. Okay, let's go to example 2. If we'll see, in this case we are selecting nodes which are at level 2, 4 and 5. If you'd have selected first child 3, first root node, then we wouldn't have selected 4 and 5. We were given option like selecting 1, 3 and 1. In that case we would have made a profit 8, but the maximum profit we can make when we are selecting nodes which are at level 2. So in this case we are making profit 9. Okay, in this example, basically if I am selecting this node, basically 4, I will not be able to select 1. Okay, let's say what are the cases possible in this example. If I'm selecting node 4, then I have only options here left basically. Okay, then basically the next selection will be done only in the remaining 2 or 3 node, basically the node with value 2 and 3. Okay, if I am selecting, let's say if I'm selecting 1, let's say 1, then if let's say if I'm not selecting 4, then what are the options possible for me here? I can select any node like within 1, 2 and 3 basically. Okay, so basically let's go to the first selection. Okay, now let's say if I've selected 4. Okay, what options I am left with 2 and 3. Now in the second iteration what I did, let's say if I select 4 plus 2, then what options I am left with? I am left with none. I'm left with 0 elements basically. Okay, because if I'm selecting this element in this selection, then I won't be able to select 3, so I'm left with no element. Okay, in this case let's say if I'm not selecting 2, okay, then what element I'm left with it? I'm left with 3. Okay, so in this case what is the maximum profit I'm getting? I have selected 4 and 2, then the profit here comes is 6. Okay, if I'm not selecting 2, then I'm left with 4 and I have to make a selection in this option. If I'm selecting 3, then what happens? 4 plus 3. If I'm not selecting 3, then simply 4 plus 0. Okay. And what's the profit here? It's 7. Okay. And here was the profit? It is 4 only. So this is one of the case. Let's say if I'm selecting 1, I'm not selecting 4. I am just selecting, I'm not selecting 4. So what are the elements left to me? 1, 2 and 3. Okay. Let's say I selected 1. Then what are the options left with me? 3. Okay. If let's say, and the second case is I'm not selecting 1. Then what are the elements left for me to select? I'm left with 2, 3. Okay. Here there are two cases, either I select 3 or either I don't select 3. So in this case, what options are left for me? 1 and 1 plus 3. Okay. Here was the profit I'm making? 4. Here the profit is 1. In this selection, if I'm making 2 as my selection, then I'm left with no element. If I'm not making any selection, if I'm not making any selection, then I'm left with 3 element. 3. Here, either I can make a choice 3 or either I cannot select. Okay. So you will see what are the profits I'm able to make. I'm making 6 as one of the profit. Sorry. Okay. Here I am making 6. Here another profit which I can make is 7. One is 4. Here again with this selection, I'm again getting 4. One is 1 basically. So these are the options possible to me. And what's the maximum here? Here maximum is 7. And how we are getting this? When I am selecting this 4 and I am selecting 3 basically, then only I am able to make the maximum profit 4 and 3, which is 7. Okay. So in this case, what's the maximum profit is 7. Now let's check example 2. In this case, what is the options available to you? Okay. So if here, what is the option available to me? If I'm selecting 2, okay, then I am just left with one option, which is 4. Okay. If I am not selecting 2, then what are the elements possible for me? Either I can select 1, 3 or 4. Okay. So I am left with 4 selection. Here, what are the cases possible? Either I can select 2 plus 4. Either I am not going selecting. So in this case, was the maximum element possible? Was the maximum value possible here? I mean, was this possible value here is which is 6. Okay. In this case, let's say if I'm selecting 1, okay, 1, then I don't have option. Then what are the selection possible for me here? I can make another selection 3. It's not connected. It's on the same level, but it's not connected. So only possible element is 1 and 1 plus 3. I won't be able to select 4 because it's connected. Okay. The another selection which I can make here is either selecting 3 or 1. That's actually comes in this category only. Okay. I'm not selecting 1 and 3. I'm just selecting 4. Okay. So here, if you'll see 1 plus 3, we got 4. So what are the possible values? Sorry, and one more thing. Sorry. Okay, sorry. Just sorry. I'm just reversing few of the steps. Okay. Let's say if I'm selecting 1, then what are the possible elements which is left for me for selection, it's 3. I cannot select 4. Why? Because it is connected directly with 1. Okay, and let's say if I'm selecting 3. Okay, let's say if I'm selecting 3. So what are the element uh, possible for me for next selection? And it is 4. Why? Because 3 is not directly connected with 4. Okay, so this I can select. Okay, and okay, and another selection possible for me here is I'm not selecting 1 and 3, I'm just selecting 4 directly. Okay, so if we'll evaluate this expression, I'm getting 4 if I'm selecting 3, or I'll be getting 1. Okay, another possible selection basically. In this case, either I'm selecting 3, either I'm selecting 4, either I'm not selecting 4. If I'm selecting 4, then I'm getting 7. If I'm not selecting, then 3 is the maximum value. Okay, maximum 3 is the value possible here. And so if we'll see what are the possible values when we have make this selection. One is 6, another is 2, one is 4, 4 basically. Here 7 I'm getting and 3 I'm getting. Okay, and one more value, 1 I'll be getting if I'm not selecting 3 elements. Third basically. So what's the maximum value here possible? I'm getting when I'm selecting 3 and 4. Here the maximum value which I got here is 7. We'll be solving this problem by recursion. Okay, and what will be our base case? If um, basically if our root node, basically let's say this is the function. Okay, what will be the, let's say return type is int, and node I'll be given node root node basically. Okay, what will be our base case in this? If root is null, basically am I going to am I going to select anything? No. So simply we'll be returning 0. 0 is the profit which he'll be able to make. Okay, if let's say I am given an option root ka left, if it is a leaf node basically, leaf node. Okay, and root ka right is equals to null basically, then I'll select this node. Okay, because if I'm not selecting that node, whatever sum I am getting, that will definitely be less. So it's wise to select that node. Okay, so basically root ka data I'll be selecting. Okay, now these are two base condition. Okay, now first case is pick. Pick means basically I'll be picking the root node. Okay, uh, that is basically I'm considering into pick, actually this variable pick basically if I'm selecting the root node. Okay, so let's say if I'm selecting root node, root data. Okay, so what are the cases possible? If I'm selecting root, basically this one, I won't be able to select 1 and 3. Okay, I'll be left with this option. Okay, but I cannot directly write, I mean, what options basically, since in this case we don't have left child of this one. Similarly, for root node 3, I don't have any right and left child. Okay, so we need to make sure that we have to check all the condition. Okay, so let's say just give if I'm picking, basically root node. So what I'll be doing, if root dot left is not equals to null, null basically, then pick plus will be function call root का left child, okay, plus function root का left dot right basically. So this is one of the condition. If its left child is not null, then what I'm doing, I am considering its left, I'm considering, I mean, the left and the right child of its children as one of the option, with one of the option. And if basically root ka right is not null, then pick plus basically will again be calling for root ka right, left, okay, and root ka right comma right basically. Okay, so these are the options available for me if I'm selecting root node. Then what are the cases possible for me? I won't be able to select the children. I'll be selecting, I have option to select from these nodes basically. Okay, and so these comes under the pick category. Okay, these are the options available to me, and it all depends upon me whether I'm selecting among all these 4 options or not. Okay, now let's say if I'm not selecting int not pick, okay, if I'm not selecting this node basically root node, so what are the options available for me? The options available for me is its children. Okay, so I don't have to check whether it's right or left childrens are empty or not. Why? Because root here is not empty. That's then only it actually came in this pick and not pick condition. Okay, so I'm simply calling root dot left plus function call root dot right. Okay, and what I'm doing, I am just uh, checking if I'm just returning the maximum value of if I'm picking the root node or if I'm not picking the root node basically. Okay, so this is the recursive approach. In this recursive approach, we are calculating the sub problems multiple times again and again, which is inefficient, and that's why we will introduce memoization. Okay, in memoization, what I'm going to do is I will just I'll just create a hash map. Okay, hash map where node base. Okay, I'll create a hash map basically. Okay, and here what I'll be doing is I'll be taking node as the key and integer basically, which is base integer basically the sum we have calculated at that node. Okay, and okay, and what I'm going to do is this is the hash map. Okay, and instead of returning, what I'll be doing, I'll be storing the maximum value. First of all, I'll be checking here if I'm at this node and we have this node stored, then it simply means we have already calculated for this node actually. Okay, I'm just going to return the rather than calculating pick and not pick. This is basically called here. Okay. Um, okay, I'm not going to calculate for this node anymore. And if it is not there, then I'm going to calculate pick and not pick if I'm okay. And I will basically add it in um, root. Root will be the key, the current root, and what the sum I'm getting, which will be basically math.max pick comma not pick. Okay, so basically this will always be this will basically be saving the sum, the maximum sum which we have got till that root node. Okay, and hence we will be calculating, we won't be calculating basically won't be calculating sub problems multiple times. Okay, and the time complexity here will be uh, order of n. Okay, so this is my lead code solution, is the same which I have written before. The time complexity of this solution is order of n, and since we are using hash map, so we have space complexity which is also order of n. Okay, so yeah, that's all. Thank you so much.